This is Mission Impossible DevSecOps with your Docker in Action authors, Stephen Kensley and Jeff Mikaloff. Today, we're going to talk about how to integrate security into your delivery processes. And this is pretty hard. So I want to set this up with a scenario that might sound familiar to you. So let's set the stage real quick. Imagine you're a fraud analysis team and it's a few weeks before Black Friday, and your product manager comes to you and says, we'd really like to integrate data from this third party to combat this new form of householding fraud. You're at your backlog or meeting or sprint planning kind of a thing, and you discuss for about 5 minutes and you say, yeah, we can do it, but we only have time to do this the quickest thing possible. And everybody in the room kind of know what that means. It means that there's a bunch of schedule risk, and you go off and you start working, but there's all this stuff that can happen. The product manager has already told the partner, the CEO or whoever that, yeah, we're going to have this partner integration done and everybody's committed and it's going to be live for Black Friday. And now it's your turn to cash that check. And good news, you're good at what you do and you land the feature in prod before Black Friday. That's great. Everybody celebrates, and the public face is like, hey, yeah, this is good. And you should be happy about that. You hit it, you did the thing. But the question is but that there's a whole bunch of stuff underneath the covers that wasn't done as well as you really want. Now you have to carry that technical debt along. And the story isn't over, of course, because the system's in production and maybe it'll be fine. And, but maybe you'll end up in the news for a security breach. And, it might just be a matter of time. Or you can go a different route, perhaps, which is to integrate security into your delivery processes. And so you can deliver those features under pressure with the security you and your customers want. I'm just trying to set the stage here for what it is that we're talking about. Of course, security doesn't end with getting the thing out there. Of course, it's continuous operations. It's not that we lack good intentions. It's just that reality interferes. Engineers want to build great, safe products. Business wants to change faster, and customers need data security. So it's just that there's a lot of the problem is over-constrained is one way to think about it. And this is getting faster and faster. We need to deliver changes faster and faster.
I think, on that, there's a tension between focusing on the end state. There's a tendency to focus on the end state, right? And that's to say we are secure or not, or this feature is done or not. And as a result, it becomes either people don't know that they should think about how you get to the end state or how you can use that path to the end state to harden things downstream. And almost always people lose sight of the fact that this is especially security and operations are things that are never done. And so if we think of, if we take on highly manual processes for either delivering something or asserting a secure state, then it becomes either something that we have to remember that we do every single time and plan for that, or it's something that is done once and then never again. And you risk all sorts of issues.
Yeah, right? That's right. And so one of the principles of DevOps is that we're going to be breaking our batch size down and delivering incrementally so that we can deliver change in small chunks and reap value in small chunks. The premise of doing an analysis once, it gets invalidated. You're constantly invalidating it if you're constantly delivering value. So, there's definitely tension there. And that's what one of the big things that, we want to help you understand some paths forward on accomplishing and building secure systems, because it's genuinely difficult. This is a practice, just like data science, like web development, like 24/7 operations. Security is like a very specialized field. Like, so we can't just ignore it and like do it on the side and like have a chance to succeed. What you think is the hardest part of securing application deployments? We're not going to do the full Slido thing. But we've been asking this question and helping people answer this question for quite a while. We'd like to understand like what it is that you think is the hardest part of securing an application deployment, and we'll share our perspectives on what that is and like how that ties into actually delivering secure systems. I'll kick it off, and I'm sure Jeff is going to add on to this. In interviews, surveys, and so forth, I hear a lot that it's hard to get security right. There's a lot of things, especially when you're provisioning something like access is a good example. You often think about sort of the positive case. I need to give somebody some access, but maybe you forget to deny some access. Or like, there might be like overlapping sets of things, and you like implicitly give somebody access to something that you didn't intend. And then there's a downstream thing that is difficult to validate. Like, maybe I thought of all the things to give access to, but like I can never be sure that I actually did that correctly. And somebody can find a hole to go through.
To add to that, I mean, it's not even that it's even that description is an oversimplification, because no access control decision is a one and done. These are things that have life cycles. Being able to think about and identify and somehow classify how and when your access control needs to change, and how it needs to change, it's all related. We really can't think of this as like a one-time deal, because just the nature of the beast is that it's going to change over time, either as your system evolves or as people come and go, as the data changes, as the users in your system change. It's even more complicated than is represented here, I'd say.
Yes, for sure. This is distilling stories into 4-word bullet points.
Right.
Right. But the results, I think, are familiar too. Specialists who know how to analyze these things are overloaded, and either your project is delayed because you're doing some analysis or doing some implementation, or you just defer it. And even if you get a waiver, that's not success. Like that's not security. And this is going to keep coming because continuous delivery, infrastructure automation technologies like Docker, they really enable you to go faster. And we've got some science now from the research presented in Accelerate that shows that this drives positive business outcomes. So this wave is just going to keep coming. So like, how do we, what's the solution? So my background is in systems engineering, academically. And so there's a great body of research in the safety and reliability engineering community. And I'm going to share some ideas from Dr. Levison. And and this comes out of Engineering a Safer World, and there's a practice called STAMP. What Dr. Levison says is that safety is a system property, and that we can't guarantee the safety of a system by only examining a single component or making that single component safe. Everything interacts together. Like we build and deploy complex systems. And so, take something as simple as an S3 bucket. You in many systems, you can't say that the objects in every bucket in AWS, in your AWS account, should always be private, because perhaps you have like you serve a website out of one, and yeah, you should use CloudFront to keep it private. The point is that there's a lot of edge cases, we might call them. There's just a lot of variation in our systems. And so we have to think about safety as a system level property as opposed to individually isolated components. Now we're going to have to design components in such a way that we can compose them and have them work together so that they're secure. But we have to think about the system, and information security is an aspect of system safety. So there are many hazards to information security that can result in real harm to physical, business, or financial losses. And if you're interested in the intersection of systems engineering and safety, I highly recommend you check out Engineering a Safer World. It's fantastic, and it's useful because systems thinking provides a path forward. And the key idea in STAMP is that instead of focusing on preventing failures, that we shift our mindset to defining and enforcing constraints. So, I'll talk about preventing failures as sort of like the magic firewall solution, or, there's like this Swiss cheese model where as long as, our defenses are such that like, the holes don't line up in the pieces of Swiss cheese, like we're all good. So the idea in STAMP is that we define and establish safety constraints for the system and let the control plane, the control system, enforce and converge operations to desired state quickly. So people who have been doing DevOps and infrastructure as code and like containers, this is actually a pretty familiar thing. An example in the container space is that, when you run a container, the Docker runtime will try to keep it running up until the number of failure attempts you configure in the retry. If it fails, it'll try to restart it. At a system level, like we want to be able to do things like a thermostat does. We want to be able to find security similarly, our goals for security, similar to how we treat a thermostat, in that let's keep our temperature in a certain range, 72 to 78 degrees, let's say. And like the thermostat's job is to like keep things in that range. And if it gets too cold, the heater turns on, and too hot, the air conditioning turns on. In our systems, we might say things like our deployed containers should not have, like when we build a container image, they should have no critical vulnerabilities in them, as an example. And part of making them available for deployment to production is that they still have, less than a certain vulnerability score. What we can do is then create libraries and processes and all kinds of supporting systems, support within our systems to like enforce these constraints and keep our system safe. Let me stop there. Jeff, what are your thoughts on that?
For me, I think that what we need is to bring this back in a concrete way to make it achievable, because we can talk about this at a very high level, but it comes off pretty academic. I think that the thermostat example is really good. We understand that generally as a population that are used to thermostats, especially smart thermostats. How do we bring this around to security? I mean, I think I can think of several ways, but
so most systems are going to have a bunch of rules in them. Like for instance, you might, and the thing is these rules, these constraints, they're actually going to vary by what part of the organization you're in, what part of the delivery lifecycle you're in. So a good example might be that you should never be able to delete a production database. In dev, at least there's some people that need to be able to delete databases. And so this highlights some of the complexity of the environment and the kind of systems we build, there are certain things that we need to have, but there are certain capabilities we need in order to be able to go fast and develop and deliver changes quickly. And there are other things that like we need to be able to always satisfy the don't delete your production database constraint, or don't leave confidential data open.
Or don't do it unless you need to.
Right. And then
right.
There's always an exception process.
Right. but make that a modeled exception.
That's right.
That's right. Kind of
That's right. And this actually brings up one of the most important things. So STAMP says, or it's got this idea that accidents happen when system constraints are not successfully enforced. And I've added this thing where they're missing, that like we just don't even, we don't define them. I think that's actually probably the most common issue I run into, is that like we're just not even thinking about this because it's all about hitting some date. And then you get into the sticky bits of like how they need to vary across the business and delivery lifecycle. So
yeah, I mean, but again, like that hitting that date is ultra end state focused, right?
Mm-hmm.
And I know that we have a very specific example that we're kind of talking through today, but I mean, in general, there's for the most part, if you're in the business of delivering business machinery or publishing, digital artifacts, then this is something that it's not really a question you should be asking yourself on a one-off basis. Is kind of the point, right? Like, how do we use the lessons learned in one case to inform how we should be thinking about these things more broadly, and how we deliver everything that we deliver, whether it's a service or a published application or anything like that.
Right, exactly. So basically this comes down to, we need to define what our safety constraints are, and then like actually engineer that security, the security controls into the system. And so returning to our fraud prediction example, we might have some constraints like this, like we must preserve privacy of users' data. One of my favorites here is going to be that we only deploy artifacts in appropriately secured configurations. And that might be something that you can say at an organizational level. And that basically maps to policy, what often gets referred to as like a security policy, like a paper policy. But we need to realize that. And then an example of an application level safety constraint would be that we should only maybe predict fraud using like validated data, or like known valid data. And the interesting thing this leads to, like defining what your constraints are, it helps you set goals for security of the system, and align the team on what is it we're going to do and what is it we're going to build, like what components do we need. So I guess, Jeff, are these the kinds of constraints you were thinking about?
Yeah. Sounds good.
Yeah. So let's see how this, let's work towards application. So within information security, you often have practice called threat modeling. That's basically this step one where you identify and prioritize threats to your information. And going through that ideation process is what, that basically is an input to the activity of generating constraints, and you then specify and record those constraints in your design doc. And then that helps set your path forward for implementing controls. And this all comes together to manage risk. And there's two major classes of security controls. There's preventive and detective. Preventive is going to help prevent problems from happening. And so like an example is authentication authorization schemes, like usernames and passwords allow a system to limit a user to only their own information, and that's a preventive control. And it's also smart to log what is actually accessed, so you can verify that users aren't accessing data they shouldn't have in an audit trail. And that way you can go back and look and see if something's wrong. And that's a detective. And if you actually have a search running and trigger an alert when something unusual happens, well, now you have a detective control. A lot of effort has been spent on detective controls, and many organizations have a solid detective game. But a lot of organizations are now really emphasizing preventive controls and trying to push back security and shift it left in the delivery process, so that we can find and prevent problems from happening before they're in production and putting customer data at risk. They're generally less expensive to solve in development than production. Okay.
Yeah, I mean, that makes sense. In a lot of cases, though, we're talking about preventative, not in the same way that user authentication and authorization is preventative, but more like earlier detection or preventing unwanted changes to our production systems.